Hi guys, welcome back to Data Every Day. Today we're looking at a data set of fuel sales in the UK, and we're going to try to predict, we're going to predict if the sale was made in the last 9 years or not. So we have a bunch of different prices, and then we also have the date, and you can see the dates range from 2003 until 2020. And we're going, since this is a range of 18 years, so the data is pretty evenly split between the first 9 years and the last 9 years. So we're going to try to predict whether or not a sale is from the first 9 years or the last 9 years. And we're going to use a large variety of different models to make our predictions, namely logistic regression, support vector classifier, decision tree classifier, MLP classifier or neural network, k-nearest neighbors classifier, gradient boosting classifier, random forest classifier, and an AdaBoost classifier. So I'm going to go ahead and import all those, and then we'll load in the data using pandas.readcsv. Note I also imported NumPy and pandas for working with the data, and the standard scalar and train test split function from sklearn for pre-processing. We can go and get the CSV file right up here, and copy the file path and paste it in, and we can take a look. So we have 8 columns in total, and you can see the first one is unnecessary. It seems like it's just an index column starting from 2 for some reason, but we're just going to drop that one. Let's get a little info on the data. We can see if there's any null values here, and it looks like there are none. We have 909 entries, and in each column we have 909 non-null values. We also only have one object column, because this is a string. And I guess without further ado, let us start pre-processing. So I'm going to get a pre-process inputs function here. It's going to take in a data frame, and it's going to return, we'll first have it return df just on its own. We'll modify this. I'm going to start by making a copy of the data frame. And so now, if we have, I don't know, let's say x equals pre-process inputs passing in data. X is just currently the exact copy of the data frame, but now what we can do is go in and add pre-processing steps in the function and sort of filter the data through and see how it turns out at the end. So the first thing I want to do is just drop this unnamed column because it's not useful. So drop ID, or actually index column, and that's df equals df.drop unnamed 0. And we're dropping from axis 1, which is the column axis. And now if we run this, check it, you'll see that column is gone. Alright, so the data is very clean, and it's all numerical. So no worries about filling missing values or encoding or today. But the date column, we're both going to generate 2 new features, which will be month and day from the date column. But we'll also be getting the year, which we'll use as our labels. So let's here generate date columns. And to do this, I'm going to use a pandas function called toDateTime, which will convert a string into a datetime format. I'm not sure if it'll work on a string alone. Let's see. Yes, it will. Okay. So it takes a string and turns it into a datetime object, which we can then use .year to get the year, .month to get the month, and .day to get the day, which is very useful. And you note that you do not have to pass a string in here. We can actually pass a column in, and it will turn each one into a datetime object. You can see the data type here, datetime 64. So up here in the pre-processing, I'm going to grab the date column and turn it into a datetime object using datetime object column using pandas.toDateTime. Like that. And then we're going to generate 3 new columns. So we're going to get a year column, which is going to be the original date column, which is now in datetime format, with a lambda function applied, turning every element of it, which is given by x, into x.year. So if we run this, you see we now have a year column that actually extracted it from the datetime object in here. And this actually is already an integer form. It pull it as a string, so it's a very nice way to do that. We're now just going to do the same thing for month and for day. So this will be month, and this will be day and day. So run that, and you can see we now have all three columns. We no longer need the date column at the beginning, so I'm just going to drop that. df equals df.dropDate, dropping from axis 1. And now you'll see the data set is in, it's almost ready to train some models on. Last is, we're going to take the year and separate it from all the rest, because that's what we're trying to predict. But first, I want to actually create the labels. So I'll create labels from the year column. So what I mean is, let's take a look at Y. Actually, sorry, year column. Yeah, let's just split it. So I want to return the year column separately from the dataset, because the year is what we're trying to predict. So I don't want it to get mixed in with the rest. So I'm going to create Y, watch I say split df into X and Y. So Y is going to be the year column. This is what we're trying to predict. So it's df sub year, and I'll just make a copy of it. And X is going to be everything except the year column. So df.drop year from axis 1. And I'll make a copy of that as well. Then instead of returning df, I'm going to return X and Y. And so this will now store an X and Y into from preprocessed inputs. I have to run this. Okay, now we have X, and you'll see the year column is gone, and we also have Y, which is just the year column. So now, note that if I currently check all the values in Y, the unique values, you can see we have a fairly even number of each value. But I want to simplify the task a little bit, and like I said, I want to separate it between the first 9 years and the last 9 years. It's not actually sorted, but basically, if we look at just the unique values without the counts, we have 2003 through 2020, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 2003 to 2011 is going to be our first 9 years, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 from 2012 to 2020 will be our last 9 years. So what I'm going to do up here, basically if it's 2012 or above, we'll set the value to 1, and if it's less than 2012, we'll set it to 0. So all we have to do is take the year column, and we're going to apply a lambda function to it. It takes in a given x, which will be one of these years, and it's going to set x to 1 if x is greater than or equal to 2012, and otherwise we'll set it to 0. So now if I run this and I take a look at y, there's only 2 unique values, and it looks like this, just ones and zeros depending on the original year. And if we look at the value counts, you'll notice there's a fairly even distribution between the classes, which makes it nice for our models. We don't have to worry about imbalanced data. Okay, so the last thing to do is now scale x. So we're going to scale x so that each column in x takes on a similar range of values. This improves the performance of many models, so it's a good idea to do. And we'll scale x with a standard scalar. So a standard scalar will give each column a mean of 0 and a variance of 1, so that most of the values in a given column will lie between -1 and 1. And we can create a new scalar object with the standard scalar from sklearn, which I imported earlier. And x will become scalar.fitTransformX. So this will just apply the scalar transformation to x and store it back in the variable. And that actually returns a NumPy array, so I'm going to set it back to a data frame after the scaling is complete. And I'm going to keep the column names the same as they were before. So now you'll see each column now takes values very close to 0, and also the means of each column will be centered at 0. Y is still 0s and 1s, and I believe we are ready to train. So I first, before we actually start training, I want to split the data into a train and test set. So we'll do that with the train test split function from sklearn, and that's going to take in our x and our y, and we'll specify a train size. How much of the data do we want to send to the train set? So 70% is pretty standard. We could do 80 too. I think 70 should be fine. And include a random state of, this can be anything, but this function also shuffles the data before it makes the split. So the random state will ensure that the shuffle is always made in the same way. And that will return 4 new sets of the data: xtrain, xtest, ytrain, and ytest, where the train sets will contain 70% of the data and the test sets will contain 30%. Alright, now we have our train set and test set, and we're going to create our models. So the models, I'm going to create a dictionary of models that's going to map a model name to a actual model, instance of a model. That's just a sample. We're going to actually get our models from up here, which are all these different ones we imported. And for the sake of time, I will just copy this in from what I did before. It's matching the name of the model to the actual instance of the model. So this way we can reference, we can get models dot keys to get the names, and models dot values to get the actual models, and models dot items to get them both as tuples. So what we'll do is we want to train each model on the train set. So for model in models dot values, so here we only want to get these guys, right? We don't care about the names. Model.fit xtrain ytrain. So we're going to fit each model on the train set, right? And they finished. And now we're going to print out the results. So we're going to print model accuracies. And then for every name comma model in models.items, so if you look models.items, we'll return a, actually it's a list of tuples matching a name to a model. So if we iterate through name model, we'll get each element in each tuple, we'll get 2 at a time, a name and a model. And then we're going to print out the name, and then we'll have a colon and a space, and we'll format the accuracy with 2 decimal places, and we'll also put a % sign, and we're going to get the accuracy from model.score on the test set. So this is our test accuracy, xtest, ytest. So I could say model test accuracies. And then we want to multiply the score by 100 so that we get it in a percentage form. And here are our results. Let me just make it a little nicer. Maybe I'll even include one of those lines. We could do a little more. 1, 2, 3. All right. And we don't need this at the end. Okay, so it looks like we had some pretty good results from all the models, and it looks like the ensemble methods performed the worst. Random forest didn't do so badly, but gradient boosting and eta boost did not perform nearly as well as some of the more simpler models. And in fact, the decision tree, which is arguably the most simple model, had the best performance, with a 98.17% accuracy. I guess that will be it for today's video. Thank you so much for watching. I hope you enjoyed. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.